Now let's go over a sample standardized test question by modeling with linear functions. Let's begin with the important information about this question. A city plans to implement a composting program. In the composting program, food waste will be collected from residents and sent to one of these compost collection sites. We have FW Processing that is 12 miles away from the city and charges a fee of $50 per ton of compost. Hayward Ecology is 60 miles from the city center, and its fee per ton of compost is $36. We have Jasper Organics, which is 70 miles away from the city center, and it charges $45 per ton. Northwestern Recycling is 95 miles away from the city center, and it charges $40 per ton of compost. And finally, Milton Recycling is 26 miles from the city and charges $65 per ton of compost. It's also important to note that operating the trucks used to transport the waste costs $1.25 per mile driven, and each truck can hold 20 tons of waste. Part A. Based on the given information, determine which composting collection site is the cheapest. Describe the steps used to determine which composting site is the cheapest, and explain any assumptions that were made. Then create a model that can be used to find the total cost of disposing food waste based on the number of tons of composting with the cheapest composting program. Describe the steps used to create your model. Let's begin by determining the cost per ton of compost for each collection site. Keep in mind that the trucks would need to make a rounded trip from the city center to each site. So they would have to go from the city center to FW Processing, for example, and then from FW Processing back to the city center. So for FW Processing, we are going to take the unit price per miles driven, which is $1.25, and we're going to multiply that by 12 miles times 2, and this $1.25 that we had was per mile driven, so I'm going to put the unit miles down here, and we can see that the miles unit measurements cancel one another out, and if we multiply straight across, $1.25 times 12 times 2, we'll end up getting $30. Now we need to find the cost per ton. And so far, we only have a cost, and we haven't taken the amount of tons of waste into account. So each truck can hold 20 tons of waste. So now we need to take the $30 that we found and divide it by the 20 tons of waste that each truck can hold. And when we do the division, we'll end up getting 3/2, or 1.5, or 1 5/10, which is $1.50 per ton. The final step in finding the cost for FW Processing is to take the fee, which is in dollars per ton, and add that to this $1.50 per ton value that we found. So the total cost for FW Processing is going to be $50 plus the $1.50. So that'll give us a total of $51.50 per ton of waste. Now let's look at Hayward Ecology. So Hayward Ecology, we have still the $1.25 per mile driven, so we'll rewrite that one down because each truck has to do that regardless, and that's per mile. And this time the truck would have to drive from the city center to Hayward Ecology and then back to the city center. So that's going to be 60 times 2, or if you wanted, you could do that right away, which would be 120 miles. And we can see that the miles again cancel out. And this will be $150. And then if we take the $150 and divide it by the 20 tons that each truck can hold, that will end up being $7.50 per ton. And then the final cost for Hayward, I'll use HW as an abbreviation, will end up being this $7.50 per ton plus the fee in dollars per ton of 36. And then when we add these together, we will end up getting $43.50 per ton. Now let's look at Jasper Organics. If we compare the distance from the city to Jasper Organics and Hayward Ecology, we can see that this is further, and also the fee in dollars per ton is also more. So we can now say that Jasper Organics cannot be the cheapest composting system. So we can cross it off most definitely, because again, these costs are higher than Hayward Ecology. Similar to Jasper Organics, Northwestern Recycling is also a greater distance away than Hayward Ecology, and their initial fee, 40, is also greater than 36. So because of the same analysis, we can cross off Northwestern Recycling because it will not be the cheapest. Now let's look at Milton Recycling. If we compare the distance from the city of 26 miles to FW Processing, it is more. It's less than Hayward Ecology, but the extra fee in dollars per ton is more than FW Processing is. So because both 26 and 65 are greater than 12 and 50 respectively, we can also cross off Milton Recycling, as it will also not be the cheapest company to choose from. So if we go back and compare FW Processing to Hayward Ecology, we can clearly see that Hayward Ecology has the cheapest rate and is therefore the most cost-effective program. Now the model for composting food waste will be the unit rate per ton of compost, this $43.50. So our cost as a function of X is going to end up being the unit rate that we found, $43.50, times X, where X is the amount of compost produced each week. And here we see another sample answer that has been written out. I calculated the cost per unit ton of compost for FW Processing and Hayward Ecology. So they did the $1.25 per mile driven times the 24 miles there and back to get to and from FW Processing. And then they took that value and divided it by 20 and then added 50 to it to get $51.50 per ton of waste. And then Hayward Ecology, they again took the miles driven, multiplied it by the total number of miles driven, divided that by 20 because each truck can handle 20 tons of waste, and then added 36 to that and got $43.50 per ton of waste. Now, This person did not need to calculate the cost per ton for Jasper Organics or Northwestern because, similar to us, they analyzed that, hey, Jasper Organics is higher in both sections here compared to Hayward Ecology. Similarly, Northwestern is as well. So their costs are going to be much more than what we already have with Hayward Ecology. And they also did not need to calculate the cost per ton for Milton Recycling because it had a greater distance and higher fee than FW Processing. As a result, at $43.50 per ton, Hayward Ecology Collection Site has the cheapest option. To create my model for the cost of disposing food waste, I'll multiply the cost per ton by the number of tons. So the model for Hayward Ecology is going to be $43.50 times X, where C is the total cost and X is the number of tons of compost. Now let's look at part B for this problem. During the previous year, the city sent 290,000 tons of waste to landfills. The cost of disposing waste at a landfill is $75 per ton. This year, the composting program will send 10% of the waste to composting sites instead of sending waste to landfills. Determine the amount of money the city will save in waste disposal costs based on the 290,000 tons of waste using the composting site that we chose in Part A. Show the process you used to determine your answer. Okay, so let's first take in and analyze the very beginning or the first paragraph of this. During the previous year, the city sent 290,000 tons of waste to landfills, and the cost for disposing of this waste at a landfill is $75 per ton. Therefore, last year, the total cost for landfills was $75 per ton times 290,000 tons. And if we multiply these together, we end up getting $21,750,000. Now this year, the composting program will send 10% of the waste to composting sites. So 10% of the waste is being composted. Let's find that out. So in this year, composting, it's 10%. So as a decimal, that's 1/10 of 290,000. And when we multiply these together, we will end up getting 29,000 tons of waste is being sent to the composting site. This will also make the remaining amount being sent to landfills be, you can either do 9/10 times 290,000, or you could subtract 29,000 from 290,000, and you'll get the same answer here, which is 261,000 tons of waste is being sent to landfills. So now let's find the cost for sending the 261,000 tons of waste to a landfill. That's going to end up being $75 per ton times the 261,000 tons of waste that's being sent to the landfill, and that's going to end up being $19,575,000. And now let's find the cost for the landfill. Oh, sorry, not the landfill, the cost for compost. We already found the cost for landfill. And we're going to use that C of X function that we had found in Part A. remember that C of X was equal to $43.50 times X, where X was the amount of tons of waste being composted. So we have $43.50, and we're multiplying this by the 29,000 tons. When we do this multiplication, we end up getting $1,261,500. And now if we add these two values up, we will find the total cost for this year. So total cost for this year, that's going to be equal to $19,575,000 plus $1,261,500. When we add these up, we end up getting $20,836,500. Now we can see that that is still less than last year, and let's see by how much. So if we take 21,750,000 and we subtract 20,836,500 from it, we will end up getting $913,500 will be saved. And here's the solution to part B. They actually did it in a slightly different way, but still came out with the same answer of $913,500 will be saved. They still first calculated the cost of sending waste to the landfill last year. That value is still the same. The cost for the landfill program this year still got that same amount, $19,575,000. But then what they did was they found the cost for one trip to the compost site and then divided the 29,000 tons of compost by 20 tons, because that's how many each truck will hold. And they found that to be 1,450 compost trips for 10% of the waste. And then they took the cost for each trip and multiplied it by 1,450 and got the same cost for compost that we did, $1,261,500. Then they added up the costs for this current year and got $20,836,500, and they subtracted and got the same dollar amount that the city will save, which is $913,500.